Okay, so onto the examples for word problems in general. This is going to be the first video. There's probably going to be quite a few videos on this, just because there's a lot of different types. And what I want you to sort of take note of is that overall, the method I apply to each individual question is less as in the actual each individual question is less important than the overall method for all the questions, which is just, I know I sound like a broken record, but it's very important, just focused on translation. So all of these problems, 700 to 800 level as usual, and I haven't seen them before. So let's get started. At his regular hourly rate, Don had estimated the labor cost of a repair job as 336, and he was paid that amount. Okay, so he was paid 336. However, the job took 4 hours longer than estimated. Okay, and so however long he estimated is, if he estimated it was T, and that equals T plus 4, that's how many hours he worked for, times his hourly rate, which we can call his regular hourly rate, is R. So he earned R minus 2. Okay. What was the time Don had estimated the job in hours? Okay, and so what else do we know? So we know that, but we also know that 336 must be equal to just T times R. And so that's our translation. And what do we want? We just want T, so we need to get rid of R. So in other words, R equals 336 over T. So 336 equals T plus 4 times 336 over T minus 2. And this is what I would say is not, there's a quadratic equation here. We could solve it for T, but to be honest, this is an example of where the maths is getting nastier than you'd like. So you're probably going to save time by instead sort of looking at the answers and testing them out. And just having a look at this, why don't we start in the middle and say, why don't we guess T is 16 and just see how that works. So if we use 16, we get 20 times 16, 336 divided by 16. So that's 21 minus 2, which is 19. And that gives us 380. So that doesn't quite work. What are the factors? We also know that let's do this a different way. We need 336 needs to be the product of two numbers. So what are the factors of 336? That could be 28 times I believe 12. And so if one of the numbers is 28, then this would work. So why don't we try B then? That's 24. So 28 times 336 over 24. That will give us 14 minus 2, which is 12 times 28. So the answer is 24. Maybe it would have been quicker to do the quadratic equation. I'm not sure. Sort of up to you. When a certain tree was first planted, it was 4 feet tall, and the height increased by a constant amount each year for the next 6 years. Okay, so we've got 4 plus 6 lots of however much it grows each year. End of the 6th year, yeah, that is 6 lots, and it was 1/5 taller than it was at the end of the 4th year. So that's equal to 6 over 5, again, just focusing on translation, times how tall it was at the end of the 4th year. Well, that's just going to be 4 plus 4x. How many feet did the height of the tree increase each year? Well, in other words, what is x? Now, this is a very easy question because we've translated. 20 plus 30x equals 24 plus 24x. So what do we have? We have 6x equals 4, x equals 2/3 d. Notice it's just about translation. That's what I'm trying to do. This year, Henry will save a certain amount of his income and he will spend the rest. Okay. So he will save, oh God, So if he saves, looking at the letters here, he saves R, then he will spend 1 minus R. Okay. Next year he will have no income, but for each dollar he saves this year, he will have no. In fact, let's not call this R. That's going to get confusing. He saves S and spends 1 minus S. For each dollar he saves this year, he will have 1 plus R dollars available to spend next year. So he will have S times 1 plus R. That's how much he'll have available to spend. In terms of R, what fraction of his income should Henry save this year so that next year the amount he has available to spend will be equal to half the amount that he spends this year? Okay, well, that's the amount he has available to spend. And we need this to be equal to half the amount. So that is equal to half of the amount he spends this year. Well, that's 1 minus S. Okay, and then in terms of R, what fraction should he save? Well, in other words, what is S? So let's just figure this out. S plus SR equals half minus S over 2. We need to get S on its own. So S 3 over 2 plus R equals a half. And so S equals 1 over 2 times 3 over 2 plus R. So apparently it's 1 over 3 plus 2R. E. There you go. All translation. Alice's take-home pay last year was the same each month. So we can just call that P. And she saved the same fraction of her take-home pay each month. Okay, so she saved X, which means she spent 1 minus X. Total amount of money that she saved at the end of the year, well, how much she saved at the end of the year? That's going to be 12X times P, because each month she saves X times P. And that is 3 times the amount of that portion. Okay, that is equal to 3 times the amount that she didn't save each month. 1 minus X. And that, we need a P there as well. If all the money she saved last year was what fraction of a take-home pay did she save each? Okay, in other words, what is X? So nice and easy now. P cancels. 12X equals 3 minus 3X. X equals 1 over 5, I believe. 15X equals 3, 1 over 5. D. The number of stamps that Kay and Alberto had were in the ration of, meant to be ratio of, 5 to 3 respectively. So that means that Kay has more stamps than Alberto. So we can say 3 lots of however many Kay has is equal to 5 times however many Alberto has. That's how we can use that ratio. After Kay gave Alberto 10 of her stamps, so now how many does Kay have? Well, Kay now has minus 10 and Alberto has plus 10. The ration ratio is now 7 to 5. So now again, Kay has more. So we want 5 lots of this is equal to 7 lots of this. As a result of the gift, Kay had how many more stamps than Alberto? Okay, so we want to know effectively what K and A are. So we can just sort of start, to be honest, yeah, we have to solve this. Okay, so 5K equals 7A plus 120. We can say that K is 5A over 3. So 5 times 5A over 3 equals 7A plus 120. Remember, these are 700 to 800 level questions, so they're meant to be hard. 25A over 3. That's not seeming right. Yeah, no, it is. 25A over 3 minus 21A over 3, because that's 7A. So that's 4A over 3 equals 120. Finally, we get that A equals 90. And that means that since K is 5A over 3, that's 30 times 5. So K is 150. And so after the gift, K is 140 and A is 100. And so the answer is 40. Okay. Dara ran on a treadmill that had a readout indicating the time remaining in her exercise session. When the readout indicated 24 minutes 18 seconds, she completed 10% of her exercise session. Okay, so that means 0.9 is left of the length equals 24 minutes and 18 seconds. The readout indicated which of the following when she completed 40%. Well, when she completed 40%, we've got 0.6 L equals question mark. And 0.6 L is just 2/3 of 0.9 L. So in other words, we just need to times this number by 2/3. And so sort of doing them individually, we get 16 minutes and 12 seconds. And so the answer is E. Okay. Before being simplified, the instructions for computing income tax in country R were to add 2% of one's annual income. So, okay, if we call one's annual income I, yep, that's there. So we add 2% of that. So I over 50, that's 2% of I. Oh, oops. I over 50. That is added to the average arithmetic mean of 100 units of country R's currency and 1% of, Jesus, I over 100. And the average of that you need to divide by 2. And then basically just simplify that. So that's in other words, I over 50 plus 50 plus I over 200, which, just looking at the answers, that has to be, 5I over 200, so I over 40, that one. For each trip, a taxi charges a fixed fee of, so that the cost is equal to 2 plus, I don't really want to do half miles, so plus 1.5 of the miles. Yeah, that seems right. For every number x is defined to be the least integer greater than or equal to, x is defined to be the least integer greater than or equal to x. Okay. Which of the following represents the countryside dollar for a trip that is R miles long? Well, it's just, oh, what a nasty little last bit. Well, okay, maybe we are going to have to do the thing in halves. So C equals 2 plus 0.75 times the number of halves rounded up. And so that's going to be, yeah, 0.75 times 2 of the sets of miles, because that's how many half miles we've got. And so the answer is E. Each of the cucumbers in 100 pounds of cucumbers is composed of 99% water by weight. So they've got 1 pound of non-water. After some of the water evaporates, the cucumbers are now 98% water by weight. Well, they've still got 1 pound of non-water. So 1 pound is equal to 2% now. In other words, what's the new weight of cucumber in pounds? Well, if 1 pound is 2%, then overall it must be 50. Okay. Pool can be filled in 4 hours and drained in 5 hours. Okay, so filling is at a rate of 1/4, and draining is at a rate of 1/5. The valve that fills the pool was opened at 1 p.m. and sometime later, the drain that empties the pool was also opened. If the pool was filled by 11 p.m. and not earlier, when was the drain opened? Okay, so let's just start by asking ourselves, when both are open, what's the rate of filling? In other words, it's going to be, when they're both open, it's 1/4 minus 1/5. So that's over 20, 1/20. So it takes 20 hours for the pool to fill if they're both open, which means that since it took 10 hours in total, the pool must have been at least half full. by the time it opened, more than half full, to be honest. So what are we getting? We're getting, let's just sort of set up our equations. We've got 1/4 times the length of time that only the filling thing was open, plus 1/20 times 10 minus x, and because that's the length of time that they were both open, and that has to be equal to 1. And so now that we've translated this into maths, we've got well, and effectively it's find out x. So x over 4, so x 1/4 minus 1/20. So that's going to be 1/4 minus 1/20. That's 5/20 minus 1/20, 4/20, 1/5 equals 1 minus a half, 10/20. So that's half. So okay, finally we've got x equals 5/2. In other words, 2.5 hours. So 3:30. D. Remember that these questions are the hardest that you could come across. Like so don't think that these look too difficult in terms of the methods not working. This is about as hard as they get. So if the methods work on these questions, it would be far quicker on the easier questions. Running at the respective constant rates, machine X takes 2 days longer to produce W widgets. So let's just say W is 1. That's the job. So X, if Y takes T days, then Y equals 1/T, which means X is 1/T plus 2 because he takes 2 days longer. At these rates, if the two machines together produce 5W over 4 widgets in 3 days. Okay, well that's a bit useless. 5W over 4 widgets in 3 days. That means that they produce 5 widgets in 12 days and 1 widget in 12/5 days. So in other words, X plus Y equals 1 over 12/5. So X plus Y equals 5/12. There we go. How many days would it take machine X alone to produce 2 W widgets? Well, so what we can do is just find out what this math is nasty. Let's just so simplifying this, 1/T plus 1/T plus 2 equals 5/12. Now that looks a bit sort of nasty to figure out. Technically it's quadratic, but let's just sort of plug in possible values for T, because if they add up to 12, then there must be a common factor of 12. So I'm guessing T is going to be 4, because then 4 and 6. So and would that work? 1/4 plus 1/6, that's 3/12 plus 2/12, 5. Yeah, okay. T equals 4, and so X has a rate of 1/6. And so how many days would it take it to produce 2 W widgets? 12 days. Okay, nasty questions. It takes 6 days for 3 women and 2 men working together. So 3 women plus 2 men equals 1/6. 3 men would do the same work. So 3 men equals 1/T minus 5, where T is the amount of time it takes 9 women. And effectively, we just want to find out what man is and what woman is. So subbing this in, we get well, putting this all of this into here, we get 1/3T plus 2/3 1/T minus 5 6. Multiply both sides by 3, so we get 1/T plus 2/T minus 5 equals 1/2. t minus 5 is suspicious there because we can't have the bottom being negative. So I'm guessing t is, let's say, can we guess this one? T is 15 or something? 10? I'm thinking 10. Just eyeballing it. We could solve it quadratically. I haven't done it yet, so why don't I just sort of show, if you don't like the eyeballing method, let's sort of solve it quadratically. So we get t minus 5 plus 2t. This really is quite nasty, isn't it? Plus 4t equals t squared. Nope. No, okay. Let's. Yeah, I really do think solving it solving it by eyeballing is better. So let's just try t equals 10. 1 over 10 plus 2 over 5. Is that equal to a half? That looks pretty good. Yep, that's a half. So t equals 10. And you notice how I'm sort of using these cheats to do it quickly, skip the hard algebra, just because the GMAT is relatively nice in what numbers it gives. So just sort of get an idea of what letters and numbers would work for t. So t equals 10, which means that man, which equals 1 over 3, so 1 over 3 times 5, so 1 over 15, and woman equals 1 over 90. So a man is 6 times better than a woman, apparently. Okay, so we've got 12m plus 16w equals 1 over 5. 13m plus 24w equals 1 over 4. How long will it take 7m plus 10w? Okay, well, we can just solve these simultaneously. So if I multiply the top one by 1.5, we get 18m plus 24w equals 1.5 over 5. In other words, 15 over 50, which is going to be 3 over 10. And that wasn't 16w, that was 24w. So why have I done that? Well, now I can just take this one and subtract the second one. So I get 5m equals 3 over 10 minus 2.5 over 10, so 0.5 over 10, which is 1 over 20. So m equals 1 over 100, which means summing that back into the first equation, we can say that 12 over 100 plus 16w equals 1 over 5. So 16w equals 1 over 5 minus 3 over 25. So 16w is going to be 5 over 25, so 2 over 25. And so 8w is 1 over 25, so w is 1 over 200. Finally, okay, and so then we've got 7 men and 2 women, so we've got 7 over 100, or in other words, 14 over 200, plus 10 over 200, which equals 24 over 200. And so the answer is 200 over 24 is how long it takes them, which is just a bit more than 8. So we're going to go with 8.3 days. Machines A and B working together take t minutes, so A plus B equals 1 over t. A working alone, A equals 1 over t plus 64. B equals 1 over t plus 25. And so now we've got 1 over t plus 64 plus 1 over t plus 25 equals 1 over t. Okay, very nasty. So the algebra here is just awful. We really don't want to solve that. That would be a cubic, in fact, if we multiply that all up. So what can we do? We can sort of have it, we have to use the multiple choice to our advantage. So A is slower than B. And so the ratio, we're immediately looking for a ratio that's bigger than 1 with A taking, so it can't be that, it can't be that, and it can't be that. And so the only options left are B and E. And so if it were and for it to be 64 to 25, that would mean that together, since we know that A takes 64 minutes longer than B, so A takes 64 minutes longer than T, and B takes 25 minutes longer than T, then if T was 0, then that would be a ratio of 64 to 25, but T can't be 0. So in other words, E cannot be the right answer, simply because when you add T to both of them, you can't keep the same ratio. And so we're left with just B. So that's an example of a question, I think, very, very nasty. I really did pick some awful ones here. But just an example of a question where the algebra is useful to sort of, get an idea of what's going on, but then it's just too nasty to finish off in that way. So you have to use sort of the multiple choice aspect and use sort of a range of different things to get towards the answer. Okay, working together, printer A and B would finish the task in 24 minutes. A plus B equals 1 over 24. Printer A alone would finish the task in 60 minutes. Finally, we get one where we actually know some numbers. And so then we can just immediately get what B is. B is equal to 1 over 24 minus 1 over 60, which is equal to 2.5 over 60 minus 1 over 60, so 1.5 over 60, which is 3 over 120, which is 1 over 40. Okay, how many pages does the task contain if B prints 5 pages a minute more than printer A? Okay, well, so then we know that, well, we've got 24 minutes in total. And we know that, so in 24 minutes, B completes, well, if B prints at, B prints at sort of a rate of X plus 5 compared to A. And A prints at X. And what can we say about B compared to A? Well, B is equal to 1.5. B is 1.5 times faster than A. And so in 24 minutes, so in other words, X plus 5 is equal to 1.5 times X, because we know B is 1.5 times faster than A. And so X must be 10. No, yes, 10. And so therefore, well, B prints at 15 pages a minute, A prints at 10, so we've got 25 pages a minute, 25 pages in 24 minutes, so we've got 600 pages in total. Okay. It takes 6 technicians a total of 10 hours to build and program a new server from direct computer. So, so one technician will be at a rate of it will take 10/6. So it would take him 10/6 hours. So his rate is 6/10, which is 3/5. And 6 technicians start to build the server at 11 a.m. and 1 technician per hour is added beginning at 5 p.m. What time will the server be complete? Okay, so before we've even started adding them, how many hours passed? We've had 6 hours passed. So in other words, well, it takes them 10 hours in total. So we've done 3/5 of the task, and so we've got another 2/5. And then in the next hour, from 5 p.m., how much is done? Well, we've got oh wow, I made a big mistake at the start. 1 technician is not 6/10. 6 technicians take a total of 10 hours, so 1 technician would take 60 hours. T is 1/60. There we go. Okay, and so at 5 we've got 2/5 left, and so 1 technician per hour is added beginning at 5 p.m. So at 6 p.m. we've had another. We've had 7 technicians working for another hour, so we've done another 7/60. So we've got 7/60 done. Then from 6 till 7, so by 7 p.m. we've got another 8/60 done. And 2/5, by the way, is going to be in terms of 60ths. That's 24/60. So we're not done yet. At 8 p.m. we've done another 9/60, and now we've done 24/60. So it will be done at 8 p.m. In a certain bathtub, both the cold water and hot water fixtures leak. The cold water leak alone would fill an empty bucket in C hours. So cold water is at a rate of, well, cold water is at a rate of 1/C. And the hot water leak alone would fill the same bucket in H hours. So hot is 1/H, where C is less than H. So that means that 1/C is greater than 1/H. So in other words, cold water is faster than hot water. If both fixtures began to leak at the same time into the empty bucket, their respective constant rates, and constantly it took T hours to fill the bucket, which of the following must be true? Okay, well, clearly it takes less than H hours if you've got both of them working together, but more than 0. So 1 is true. It certainly doesn't take more than C hours because we've got both of them working together. So this isn't true. And if it was 2 cold water taps, it would take C/2 hours. And if it was 2 hot water taps, it would take H/2 hours. But we've got somewhere in between the two because we've got sort of better than 2 hot waters, but worse than 2 cold waters. So this one must also be true. And so there's our answer, E. Tom working alone can paint a room in 6 hours. T equals 1/6. Peter and John working independently can paint the same room in 3 hours. Okay, so P equals 1/3. John equals 1/2. Tom starts painting the room and works on his own for 1 hour. Okay, so again, this type of question, we've got 1/6 of the job done after 1 hour. So Tom has done 1/6 of the job. He's then joined by Peter and they work together for an hour. So now what's happened? Well, Tom has done another 1/6 and Peter has done 1/3. Finally, John then joins them and the 3 of them work together to finish the room. Okay, so how much have we already done? We've done 2/3, so we've got another 1/3 left. So if they worked for another hour altogether, how much would we get done? So we would get another, well, it's obviously, yeah, so if we've, let's use sort of the fixed unit of time. We've got 1/3 left to do. If they worked for another hour, we'd get 1/6 plus 1/3 plus a half done, which is going to be, oh wow, but that's just one. Oh, so they work together for another 1/3 of an hour. And so Tom Peter in that time does another 1/3 of 1/3. So he does another 1/9. And so 4/9 looks like how much is done by Peter. It takes printer A 4 more minutes than printer B to print 40 pages. Okay, so A equals 40 over T plus 4 if B is 40 over T. Working together, the printers can print 50 pages in 6 minutes, so A plus B must be 50 over 6. How long will it take printer A to print 80 pages? So in other words, we need to sort of sub this in and find T. So if we sub that in, we get 40 over T plus 4 plus 40 over T equals 50 over 6. Now, again, I could solve this algebra by multiplying through for T. The only problem being that will result in a pretty nasty quadratic equation. So you feel free to do that. It's just usually it's easier to just sort of guess T. And what I mean by that is let's simplify this a bit first. So 1 over T plus 4 plus 1 over T has to be equal to 50 over 40 times 6. In other words, 5 over 24. And so now that's actually, it's going to be pretty easy to guess what T is, because we need T plus 4 and T to have a lowest common multiple of 24. And so I'm thinking that T is just, we haven't got many options. T could just be 8, for example. And so then we get 1 over 12 plus 1 over 8, and that will be 5 over 24. So we've very quickly found that T equals 8, and that will be, in my opinion, faster than solving the quadratic. But solving the quadratic is an equally viable way if you'd rather do that. And so T equals 8, then we have A equals 40 over 12, which is 10 over 3. And so how long does it take printer A to print 80 pages? Well, that's how many pages he prints a minute. That's his rate. So times that by 80, and that's, do 80 divided by 10 over 3. That's how long it will take, which in other words is 3 times 8, so 24 minutes. Okay. Working alone at constant rate, pump X pumped out quarter of the water in a tank in 2 hours. Okay, so X has a work rate of 1 over 8. Took him 2 hours to do quarter of it. Then pumps Y and Z started working, and the 3 pumps working simultaneously at the respective constant rate pumped out the rest of the water in 3 hours. Okay, so the rest of them did 3/4 of the job in 3 hours. So all of them together would take 4 hours to do the whole job. So we can say X plus Y plus Z equals 1 over 4. If pump Y, working alone at its constant rate, would have taken 18 hours to pump out the rest of the water. So Y would have taken 18 hours to do 3/4 of the job. So in other words, 24 hours to do the whole job. So Y must be 1 over 24. Then basically it's just find Z. So we can do that quite easily now. Z equals 1 over 4 minus 1 over 8 minus 1 over 24, which looks like everything over 24. We've got 6 minus 3 minus 1 over 24, which is 2 over 24, 1 over 12. And so it looks like it will take him 12 hours to pump out all of the water that was pumped out of the tank. Working alone, printers X, Y, and Z can do a certain printing job consisting of a large number of pages in 12. Okay, so X equals 1 over 12, Y equals 1 over 15, Z equals 1 over 18. Always nice when they give you the actual numbers. What is the ratio of the time it takes printer X to the job working alone at its rate? Well, that's okay. To the time it takes printers Y and Z. Oh, okay. So, well, what's Y plus Z? That is 1 over 15 plus 1 over 18, which lowest common multiple looks like 90 to me. So we've got 6 over 90 plus 5 over 90, which is 11 over 90. And so how long does that take them? Well, that takes them 90 over 11 in hours. and X takes 12 hours. So this is the ratio. But what form do they want it in? Well, it looks like they want... oh, they don't. That's not a ratio. Okay, so they just want 12 over 90 over 11. Yeah, 12 over 90 over 11, which is 12 times 11 over 90. That simplifies down. We can take out a factor of 2, so we get 66 over... Oh, we can take out the factor of 3 as well. So we get 22 over 15, I believe. Yeah, there we go. D. Okay, and that's the end of the examples for this video. The next video will be further examples in word problems of a different type.